Alright, so today's movie is on counting atoms and symbols. It's one of the consequences of the law of conservation of mass that says that atoms cannot be created or destroyed, therefore we need to be able to keep count of how many atoms we have in a chemical reaction. So, let's start off with elements. An atom without a subscript is just one atom. An atom with a subscript is the subscript number of atoms. So let's do some examples. So, I'm going to use blue for my writing. So whenever we have the element Mg, that means we have exactly 1. Krypton, same thing, doesn't matter if it's a metal or non-metal, we have 1. Now nitrogen, we can see it's got a subscript of 2, so that means there are 2 atoms of nitrogen. And similarly, one of the versions of phosphorus has 4. So whenever you just see an element, if it's got no subscript, it's just 1. If it has a subscript, whatever the subscript is, that's what it is. Alright, so let's move it up to compounds. Alright, so the same applies to a compound. All you have to do is look for a subscript, and if there is one, that's how many there are. So here's a few examples. So now we have to break it apart into the element symbols and how many there are. So we now have to write Mg, there's 1, the Cl, see the subscript there is 2, so it's just 2. Next example, KrF4, so again, Kr, that's krypton, there's 1 of them, and the fluorine is 4. Okay, so we're just looking for subscripts, that's all we're doing. N2O5, dinitrogen pentoxide. So the nitrogen is 2, the oxygen is 5. We're still just looking at those subscripts. Now we've got an ionic compound with a polyatomic ion. No big deal. Lithium, we see its subscript is 3, so there's 3 of them. Phosphorus, there's no subscript there. That means it's a 1. We got a subscript for the oxygen. That's 4. Okay, so all of these simply say look for subscripts, and whatever the subscript is, that's what it is. Okay, so now that we've got elements and compounds, we're going to increase the complexity just a little bit. What we're going to deal with now is polyatomic ions in brackets. So if you have brackets for polyatomic ions, the subscript outside the bracket multiplies with the subscript inside the bracket. So let's see some examples. We've got 3 of them here. So just like in our last round, we're going to have to identify each of the elements individually. So let's start with the calcium chloride on the left. We're going to have Ca, we're going to have Cl, and we have O. Now, the calcium has no subscript given there, so it's just 1. Now, the oxygen is going to be easier to deal with because we can see its subscripts. The oxygen has a 3 inside the brackets, and there's a 2 outside the brackets. So the oxygen is going to be 3 times 2, which is 6. Now you don't have to show this math. Okay, so if you can do it without showing that math, then that's okay. What we want is the 6. Now, for the chlorine, we don't see the number there, so it's understood to be a 1. So 1 times 2 equals 2. Okay, so there's 1 calcium, 2 chlorine, and 6 oxygen. All right, let's look at the next one. Al2PO4 bracket 3. Now, I know that this symbol is incorrect, but we can still do the calculation. So Al, its subscript is 2, so we've got a 2. Phosphorus. We're going to skip it for a second because I can't see the subscript. We'll come back after we do the oxygen. The oxygen is 4, the subscript after the O, times the 3. That's 12. Phosphorus will therefore just be 1 times 3 because there's no subscript shown after the phosphorus, but the 3 outside still counts. So that's 1 times 3, which is 3. Okay, the last example with brackets I've got here is ammonium oxide. So we've got the elements nitrogen, hydrogen, and oxygen. Now, nitrogen, there's no subscript, so that's a 1, times the subscript outside the brackets, that's 2, which equals 2. Hydrogen, the 4, times that 2 outside the brackets, is 8. The oxygen has no subscript, so it's just 1. So that's how we handle brackets. We simply multiply the subscript inside the bracket times the subscript outside the bracket. Okay, one last piece. So the last piece is something called a coefficient. Coefficients are numbers that are put in front of a chemical symbol used to balance a chemical reaction. Balancing is how we ensure that all atoms available for a reaction are turned into products. So coefficients will always multiply all the totals from the symbol. So everything that we've done so far, we will always multiply with numbers out front. So if you're ever unsure what to do, you're multiplying. So here's some examples. So let's start with the first one, MgCrO4. So Mg, well, there's a 4 out front, there's no brackets, and the subscript understood for magnesium is 1, so it's just 4. Chromium, there's that 4 out front again, there's no brackets, so I'm not multiplying there, and the subscript is not shown, so it's just a 1, so chromium is just 4. Oxygen, there's a 4 out front, a coefficient, times the subscript 4 equals 16. So there's 4 magnesium, 4 chromium, 16 oxygen. All right, let's have a look at the next one. We have 3 elements, iron, nitrogen, and oxygen. All of them will have 2 because of the coefficient. Iron has no subscripts, so it's fine just the way it is. Nitrogen will be times 1, which is the understood subscript inside the bracket, times the 3, which is the subscript outside the bracket, for a total of 6. Whereas oxygen will be that 2 out front, times the subscript 2, times the subscript 3 outside the brackets. So now we've got 2 times 2, which is 4, times 3, which is 12. All right, so sodium sulfate. We're going to have Na, S, and O. So the sodium is going to be the 3, the coefficient, times the 2 for the subscript, which is 6. Sulfur is the 3 out front. There's no subscript, there's no brackets, so it's just 3. Oxygen, that's the coefficient 3 times its subscript, which is 4, which is 12. And sometimes you get really, really easy ones, like the last one, 3 molecules of oxygen. So O is the coefficient 3 times the subscript 2, which is 6. And that's counting atoms. Thanks for watching.